Welcome to today's presentation. I am Shakila Rahman and I am a lecturer of the Department of Computer Science in a university named American International University, Bangladesh. Today I am going to present my paper ID 21220, and the paper name Real-Time Smoke and Fire Detection Using Advanced Computer Vision and Deep Learning Techniques. So these are the some contents for our work. The first, I will start my presentation with the problem definition and solution identification. Then I will present the motivation or background, then methodology, then results and findings with some future works, and there I have also added some reference. So at first, coming to the problem definition. For example, there are some cases because of these reasons we have considered this issue for our work. Traditional smoke detection limits, there can be some speed or accuracy, and also some heat sensors may give some false alarms from some steam, which can be look like some smoke. So also there are some optical sensors struggle in challenging environment. Also, there can be some other urgent need for precise smoke detection. So, considering these issues, we have considered our problem, and our goal is to prevent rapid fire speed and mitigate dangers. So there are some solution identification. For example, as in our work, we have implemented our own YOLO-based models, so which is for some real-time smoke detection. Smoke and fire actually have considered both in our work, and also some other recent research paper endorse YOLO model in smoke detection tasks. Also, there are some CNN like convolutional neural networks proved effective in some smoke detection. So priority on achieving high accuracy, especially in challenging conditions, which enhanced smoke detection using advanced computer vision and learning techniques. So based on this, so we have considered our problem where we are considering the smoke and fire, both which is identified based on our work. So here are some motivation or background or some literature review. For example, you can see that the quality of numerous research publication is assessed, and we have a variety of deep learning techniques to increase model accuracy while concurrently reducing bias, loss, and outfitting through repeated tuning and prevention of overfitting for optimal tuning. So, for example, we have used some YOLO-based model. So, where in our proposed work, the precision, recall, and mean average precisions and detection accuracy is higher comparing other baseline algorithms. Like, for example, we in this paper, I have also added some references for this work, YOLO B7, YOLO B5, MobileNet V2, and ResNet 32. We have considered our work within these their proposed models, where we have actually considered our own data. And then in these cases, we can see that they are all precision, recall, mean average precision, and detection accuracy is lower than the proposed model. So now moving to the workflow, workflow diagram for the whole detection process. So these are the some research methodology. At first, we have collected data, then the collected data is pre-processed. Then the pre-processed and processed data is divided into two parts: training and testing. So in training, we can see that they are creating level map and configuring to YOLO V8 models. Also, there are some training with YOLO V8 models. So after that, we extract some graph and some loss graph. So based on this extracted graph, we have found some testing. For testing, we have to use some feeding data and adjusting parameters. Also some accurate prediction and fire proposal and ROI polling, region of interest polling and softness. Then after that, we found some output with bounding box. Moving to our other process. Here, for example, in the step one image acquisition, we have collected the images in three categories. We have the three classes, as I have mentioned in, I think, previous introduction part. Here we have classified, we have three classes: fire, smoke, fire, and so our total dataset, training dataset is 3990 and the testing dataset is 1130 and for validation 580 and so total dataset count is 570. So we can see that these are some sample images which is collected in from different sources. So here we can see that there the smoke and fire both are considered in this case. Now moving to the next step after collecting the data set and we have resized the data. So these are the some pre-processing steps. First we have to resize the data. Then after resizing we have annotate the data. So while annotating we have used this step. As you can see that we have considered the smoke and fire. We have considered these three classes. So after annotation, we have saved the annotated image and which is actually added in some txt files. And then after we pre-process the txt file, then we feed the model with this data for training. So now, as I have mentioned, we have used labeling. So there are some sample labeled images. Here you can see that the green portion is considered for the fire and the purple portion is for the smoke. So we can see that there are also some figures with both smoke and fire. So that's how we have annotated our data. Now, for data pre-processing, we have considered actually this stated for annotated train data, annotated test data, and after that which generated some text data. So we have both train and test data are fit for the data processing. So now for result analysis, we have analyzed some hyperparameters and some model evaluation parameters. So for hyperparameters, we have used some batch size, number of ebooks, optimizer. For app optimizer, we have used SGD optimizer, and we have used some pre-trained model of COCO model and some learning rate of 0.01, weight decay 0.001, patience 50. And for model parameters, we have used the model layers, model parameters, gradients, and some z-plots. And these are the values for this parameters. Actually, we have tested for other parameters considering this, but all these values actually are the optimized values. So now showing this for some result analysis, you can see that for some result analysis, the first one is YOLO v8-based recall confidence curve. Here you can see that the sky blue one considered for the fire and the orange one is for smoke and the dark blue is for the all plus. And these are some YOLO v8-based training curve with 50 ebooks. We can see that the loss also decreases when the number of ebook increases. And now moving to the other result analysis for the YOLO v8-based recall confidence YOLO v8 training graph with 85 ebooks. Actually, for training the 85 ebooks, we get the best results. Here we can see that after 50 also there is some fluctuations where the model overfitting actually happened here. But we got the best results in case of 85 results based on the detection accuracy and mean average precisions and some validation or class loss. So in all cases, comparing the 50 and 85, we found the best results in 85. So now moving to the confusion matrix. These are the confusion matrix diagram for the 85 ebooks. Here we can see that for fire, the detection accuracy is highest, which is 70%, and for smoke, this is 56%, and these are some background values. So in our cases, the fire is actually detected more accurately in some tested data set. So here, these are some examples of randomly detected images, which for YOLO v8 model for some random images. So the detection accuracy is higher. We can see that in the next slide. These are some like images for our proposed YOLO v8 model, and these are for the YOLO v7, YOLO v5, which is the baseline model. So in all cases, we can see that actually our model detection accuracy or percentage is higher. We can see that here in case of like ResNet 32, the second image they cannot detect. You see here also the detection is not there. So like in our proposed YOLO v8 model, the detection can detect all the images, and our detection percentage is higher than all other images. So this was our result. Now moving to the conclusion and future work. Actually, we have developed a smoke and fire detection system using YOLO-based model, and which is demonstrated superiority in accuracy, speed, reliability over traditional systems. Because I have already mentioned that in our traditional system, some CNN models also applied, or some earlier version of YOLO model is also considered. But in our cases, I think the YOLO v8-based model works better. Trained on a diverse dataset of 5700 images for high precision recall and mean average precision metrics. And we have achieved 68.3% precision, 54.6% recall, 60.7% F1 score, and 57.8% mean average precision. While the detection accuracy is 99.8%, which are outperforming other baseline models. Acknowledged limitations include the need for exploration in different environmental conditions, which is suggested exploration of obscured smoke, diverse lighting, weather conditions, and fire sources. So we have also actually encouraged integration of the model with other sensory data and real-time surveillance systems. Like for example, whenever the using in case of some CCTV cameras, so there can be some false alarm or some other cases, which was actually traditional models. So the YOLO v8 models, I think it can detect well. So I think false alarm rate can be decreased. And also there are some explore the impact of different layer parameter configurations on model performance for specific use cases, and investigate advanced techniques such as transfer learning or ensemble methods to enhance the model's capabilities. Expand the dataset to include a broader range of fire scenarios, ensuring adaptability to diverse environmental conditions. And continuously refine and update the model architecture for higher accuracy and efficiency. Address limitations such as detection loss on the background class by extending the dataset range and testing additional parameters. So this was our conclusion and future work. And here are some references for these works I have added. And thank you for listening me. If you have any questions, you can actually send me emails. I have added my email in the all slide. You can send me any email related to these works. And also these are some appendix. These are some equations which is used actually in our result calculation. And thank you for listening.